Good morning, Professor and everyone. So this is Bryce and Lucas. So we are going to introduce our smart massaging shoes today. So let's come up with our story first. So it's basically that we feel tired and painful when we have after a day of work. Then we want something comfort. So that's why we think of integrating the shoes and massage together. So we can have our aim of anywhere, anytime, comfort. Stay in your comfort zone by creating one on your own. So this is our brief content, and let's start with our journey first. We basically try our best to try everything, so including the journey here. So let's have a recap first. So this is our shoe design based on the SolidWorks, and we try to mimic the shape of the shoes. And at the bottom, we have improved the design that the cable can pass through easier, and the battery and the ESP32 can place with more efficient and convenient precision. So here we basically try the emphasizing the material here. So we mainly use the McKeever muscle for our project here. So we try to use as many properties as possible during the lesson. So including the physical properties, that will be including the mechanical properties like the flexibility and the hardness. We also use thermal properties initially, but that is failed. And we also use the electrical properties, that is from the electromagnet, and of course we have the magnet properties, that is with the electrical. And we have a recap first based on previous midpoint presentation. So we research in bimetallic strip, shape memory alloy, and dielectric elastomer actuators, but they are so common and they are time consuming mainly, so that's why we did not choose finally. And we also abandoned the choice of piezo actuator because it's difficult and it may require large size, so that's why it's not applicable. That's why it's impractical for the shoes, and it's difficult for us to make it. Also, it's inappropriate because of the size. So we have the new observation in the improved McKeever muscle here. So this is the brief example of the McKeever muscle we tried. This is, and then here we have the same material used for making the McKeever muscle. And then this is the improved version with greater effectiveness. So imagine that is the shoes here. Replace the McKeever muscle. When we give the electricity, the pump will pump up the balloon, and you see it expand, and it can create the effect of massaging. So when you put your hand below, you can feel that it's expand. So we can achieve the basic actuator, the motion here with the material bought. So we have bought the polybutadiene and the rubber tube. So these two materials will be used for massaging. They are hard and it's customized for user preference. So example, you can use different size and different hardness to create the best experience for user for material. So but this is we can make it changeable. Then we have improved effectiveness with the greater force of balloon. So we improve the design of the shoe so that the hardware stuff is more tightly and easier. And we also solder with tube management here. So and finally we have the rubber tube material choice selected. And besides the McKeever muscle, we have tried a new method of electromagnetic. So we try with some success here, a little bit voltage and current, but it's very small. So it's just a slight increase from magnetic function. So even like we try many times and we destroy many solenoid, like the ground solenoid, and then we test with the meter, so to test that if it is safe, if it has current, but it's very small though. And then we have soldered many times. So this is the trial and error. So as you can see, it can attract the magnet, but it's very weak. So compared to the McKeven muscle, so that's why we abandoned that one. However, if we use the inverse thinking of repelling magnets, so you can see here, we basically used the magnet taught in the lesson previously. So just now is the attractive force, but now it's repelling force here. So it only requires magnet actually, but because it's from lesson, so I don't want to disassemble it. So if we can just use the 8 magnet to do the repelling force, it can use as a passive mechanism already. So as you can see, when we press it, like the feet press on it, so you can have a massaging effect. So the screws are the massaging material. When you press it, the magnet will go down and the screw will act as the puncture to punch on your feet. So this can create the massaging effect with passive mechanism. And the feature, so that's why we hope that with passive mechanism, when user walk, so the foot can press the magnet and the screw will act as the massaging tools automatically. So this is the advantage of passive mechanism. So of course, at the same time, we have customized material for user, like as mentioned previously, the polybutadiene and the rubber tube. And then also we have a sample of the shoes here, and then you can see that there are many holes on it, the many points on it, so as to punch on your point on your feet. So that's why we can customize this material, and with the magnetic effect, we can have a massaging effect on your feet here. And we also have the silicone gel for comfort. Because some people may not be comfortable with the hardness of the previous two materials. So we have the silicone gel, so that when user wear it, you can the user can feel more comfort. And here, arrival of our final product. So it's basically an integration of active and passive mechanisms. So for user to choose accordingly. So when you walk, it is for sure that passive mechanism can provide a guaranteed massaging effect. But at the same time, with charging, there will be a greater effect of massaging with the McKeven muscle. But of course, like if the battery is run out, and you can still use it because the passive mechanism can provide a massaging effect. And here is the future plan, and if it is developed into business, we have to consider the following things. So the first one is the materials of choice. So that's why we need to have different sizes to point to the point of your feet specifically, and with the hardness that is made for user. So here, and also with the programming here, so we need to increase the speed or reduce the speed according to the user needs. So at the same time, so we have to control the strength of the pump, so that if user want it to be softer, then we can control the speed of the pump. And if we want harder, then we can increase the strength of the pump. And of course, we still have improvements, room for improvement. So of course, we need to have the better ESP32 hardware, pump system, because now the hardware stuff is not protected safely. So, and at the same time, the pump may not be very professional, so we may need to change it. At the same time, the shoe design for placing material, we improved, but it's not the perfect, so we have to have a better placement of the cable, of the tube here, of the tube for air, so it will be more easier and more sophisticated for the shoe design here. And at the same time, we need the better texture of material. So because that two material mentioned is just for testing and trial, so we need to have a larger choice. But that two choices are preferable, but you can refine it or see the combination possible. So at the same time, lastly is the better magnet placement and reduce the size, because that one is just for lessons, so we have to reduce the size to fit in the shoes. So this is the 4 things that we mainly need to improve in the future. And takeaways, so this is our own reflection. We did understand the materials, like different material properties and their behavior, and also we have made the mechanical skill, hardware skill in this project, like the SolidWorks drawing and the soldering here. And we also buy material, learn different material and how to collaborate together to do the massaging shoes here. So again, here is the massaging shoes for our project, and this is our anywhere, anytime comfort. And thank you for your listening, and we would like to hear your feedback.